Okay, now previously we found our delta S for the loop problem on a preceding video to be A delta theta times negative sine theta star I plus cosine theta star J. And we can, you want to think back to how we got that, but it's fairly straightforward. The R vector, and I've underlined the delta S vector in green just so we can keep track of it, because I didn't really do a great job of board management here. The expressions are long. They were going to have to wrap anyway, but I could have done better. Okay, well, then we have our R vector, which is written right here. It's in purple, so here's our R vector. So we have our I delta L, and delta L is going to be our delta S, our I delta L cross R here. And then in the denominator, we have the magnitude of R cubed. Now the magnitude of R is just this expression inside here, square root, and when we cube it, we get a 3/2 power. So our R to the 3/2, now, and that's not R to the 3/2, that's R cubed. Okay, now I've wiped out part of my cube. Is here. And I'll observe that we can factor out the a squared from these two terms, leaving us cosine squared and a sine squared. And that theta should actually be a theta star. I think I've got stars in all of my other thetas. In any case, the cosine squared and sine squared add up to 1. We just end up with an a squared here. So we're going to have an a squared plus z squared when we get down to the next step and the final step. Denominator is going to be a squared plus z squared to the 3/2 here and here. Okay, so we do the cross product. All we have to do is do the cross product, write down what we get, and do a little bit of simplification. Okay, well now I cross I is 0, so we don't have to worry about this term crossed with this one. I cross J is K. We have a negative sign here, a negative a times a sine of theta star here, giving us a positive a times sine squared of theta star. And I wrote the signs, both the sine and the sine, but that would be a sine squared. And that's times K. Then we also have the negative sine theta I crossed with zk. I cross K is negative J. We have a negative here that goes with a negative J, and it's going to give us a positive result, sine theta star times Z, and that will be times J. Then the cosine theta star J crossed with each of these terms. Of course, this one's going to be 0, but crossing with this one, okay, J cross I, J cross I, J cross I is negative K, and we have a positive cosine theta star and a negative A cosine theta star. With the negative K, that's going to give us a positive, where is it? A cosine squared theta star times K. And then the J cross K is just I. So we're going to have cosine theta star times Z times the I vector. So that's our numerator. Now we've again factored out the A delta theta here, and the I, of course, is already pretty much factored out in the K prime. And here's what we got left in the numerator, and here's our denominator as discussed before, a squared plus z squared to the 3/2. Simple. It's easy step of simplification. We have sine squared theta here, cosine squared theta here, both times K, both with factor A. So we just factor out the A times the K vector. We have sine squared plus cosine squared is 1, and we just end up with A times the K vector. And then all we have left is the cosine theta star Z times I, which we write here, the sine theta star Z times J, which we write here. So here's our expression for the delta V. Now we want to take that expression to an integral, and that's going to take a little bit of work, but it's going to lead to a really simple result. It's kind of surprising maybe that it comes out so simply, because it's fairly involved here.